All right, this is integration by parts tricks part 1. Part 2 involves u substitution with integration by parts. So part 1, we're just going to look at the basics. So what happens if you just have a single term? Well, you do the same thing. You would say u equals ln of x, and then you just say your dv is equal to dx. So what we're going to do is just say that this is dv, and this is our u. You could even make that one a 1, and it would work the same way. But we're putting it over here. So now when we take our derivative, we get du equals 1 over x dx. And our v integral would just be x. And so remember, if you take the derivative backwards, derivative of x is 1. So here we go. Now we know our integral is, we don't need to write the integral. We're just going to write it, is equal to uv, we'll write it, u dv equals equal to uv minus the integral of v du. And so now we just plug them in. Again, these two go first. So we end up with x ln of x minus the integral, and then the bottom two together. So that would be 1 over x and x. I'm going to write them in there just so we have it. Like that. And then they cancel. So we end up with x ln of x minus, I was supposed to do that in green, huh? Let's go back. I'm going to erase it and then put it in green. Integral of x 1 over x dx. This is the integral of 1 dx. You don't have to put the 1 if you don't want to. But we end up with x ln of x minus x plus c. Now what do we do when we're done? We circle it. That's always number 1. But we also check it. So we're going to take the derivative of this. So derivative of x ln of x minus x plus c. This would be 1 ln of x plus x 1 over x minus 1. And so we end up with ln of x. And then that cancels. It makes 1 minus 1. And they cancel, giving us ln of x. So it checks perfectly. All right, the next method is when you get something that seems very hopeless. So like if you take the derivative of e to the x, you get e to the x. You take the derivative of sine x, you get cosine of x. Nothing's getting simpler. So what we end up doing when this happens is we try to turn that negative v du, that second part, that integral, into the other one. And then you can see what happens when we do that. So we're going to say u equals e to the x, and dv equals sine x dx. So again, we're making this our u, and this our dv. So our du is equal to e to the x, and our v is equal to negative cosine x. Remember, we're reverse here. So derivative of negative cosine would be sine. And then I'm not going to do any red anymore, so we do that first. So we end up with negative e to the x cosine x. Now what we want to do is, since we know this is what's happening, it did not get simpler. And the way you can tell it is when I put minus and then the other two, we get the integral. Oops, I forgot my dx over here. We get minus e to the x cosine x dx. And then since there's a minus here for these two, let's put that so it doesn't look like a negative. A negative here, we got to change this to a positive. And so you look at it, it's e to the x cosine of x. It's not any simpler. So we come over here and we bring this down. So since this is what we're solving for, this left side here, this, if we can turn that second integral, maybe you can see where I'm going with this guy right here, into this one, then we can actually add or subtract it to the other side. So what we're going to do is our u again. So u equals e to the x, dv equals cosine x dx. So du equals x dx, and v equals, and now this would just be sine x. So derivative of sine x is cosine. It checks perfectly. So now, do our little arrow. We get e to the x sine x. So you can kind of see how quick this gets. Minus integral, and then the bottom two together. So e to the x sine x dx. And there you have it. Now we bring everything down. Now, let me highlight that in blue. You can see that is the same That's that. So by adding it, see, this is an equation. They're both equal. This equals this. So it's just like a normal algebraic equation. So if we take and add this to the other side, just like we would do in a normal equation, this is a trick. This is why we're doing this. We end up with two of them now. Two integral, because they're both like terms, e to the x sine x dx. So like if we had had 3 here, that would have been a 3 and a 3, and that would be a 4 now here. Equals e negative, oops, forgot the negative, very important. Okay, plus e to the x sine x. So now you can see, what do? Aha, we divide by 2. So if we divide everything by 2, we get integral of e to the x sine x dx is equal to, and then we're going to divide those by 2. So 1/2, and I'm going to just take and put the half first, negative e to the x cosine x plus e to the x sine x. The reason is I see they both have an e, and so I want to take that e to the x out. So 1/2 e to the x, and then now we'll just write it as sine x minus cosine x. And then what do we need at the end? Plus c. We need that constant because this is it's not a definite integral. And then now we need to check it. So 1/2 e to the x. In fact, we're good now. We can just take the derivative. So it's going to be derivative of the first. So 1/2 e to the x, and then sine x minus cosine x. And then now the derivative of the other one. So plus, and then it'd be 1/2 e to the x. And then derivative of the inside, we can just split them. So e to the x, this would be cosine x plus sine x. And if you look through it, you'll see that we have a 1/2 e to the x sine x minus cosine x, and then over here the same thing with a positive. So the cosines are just going to cancel, leaving us with 1/2 e to the x sine x plus 1/2 e to the x sine x, and so that would together, half plus half is 1. We get e to the x sine x, so it checks perfectly. See, right there. So always take your derivative to verify it's correct, because there's a lot of little signs in here that you can make mistakes with. So if you had forgotten that little, changing that to a plus, that would have became a plus. It would have subtracted away. You would have been like, oh, this is not working. So one more. This is now with trig identities. So sometimes they give you stuff and you go, oh my god, there's 3. Now what do I do? Well, if you look, you get 2 sine x cosine x. If you remember, sine 2x, or double angle identity, is equal to 2 sine x cosine x. So we can immediately just change it to x sine 2x dx. Now everything is great. And if you remember, we want to always pick our algebraic before our trig, because again, the algebraic will become very nice. So our u, we're going to make v, this one right here, and that makes this one dv. So our u is x, not v. Same as thinking v. dv is equal to sine 2x dx. So we get du equals dx. And then v equals 1/2 with a negative cosine 2x. Now you can use u substitution, but I would call it b substitution if you're going to do it to get here. But if you've done this enough, you already know that when you take this using chain rule, you're going to end up with a 2 in front. So what's the reciprocal of 2? It's a half. So we're going to put a half here. And then if you end up with a co, it's negative, right? All right, so we take the derivative, you get cosine 2x would become sine 2x negative, and that negative cancels it, and then derivative of that would be 2, cancels, works perfectly. All right, so now we take those two first. So we're going to get x with a negative 1/2. So I'm going to put negative 1/2 x cosine 2x minus integral, and then these two together for the ending one. So negative, we can now make that a plus. I'll just use that as a fraction. Cosine x dx. And see, what this did is get rid of the x. So now integral of cosine again is negative. Oops. We forgot that too. Well, you didn't. I did. So that would be 1/2. Let's just put it in order then. We're going to take this one slow. Negative 1/2. It's not negative. It's positive. 1/2 sine 2x. And then we check this sine 2x would be cosine times 2. So that's a half. Works perfectly. Put our plus c. So we end up with negative 1/2 x cosine 2x plus 1/4 sine 2x plus c. And if we check it with our derivative, we end up with negative 1/2 cosine 2x. And then we got to put the minus 1/2 x again. And then derivative of cosine is negative sine 2x times 2 plus, and then this would become 1/4. Oops, that's 1/3. 1/4 cosine 2x times 2. And then if we simplify this, we get negative 1/2 cosine 2x plus, and then it's just x sine 2x. So that's the one that we wanted in the middle. So hopefully the ending one just becomes the first one. And it does. And they cancel. And there you have it. So it checks perfectly. So these are your tricks. If you see trig identities that you can convert them if needed. If you see something that's not getting nicer, you didn't really have a choice here, then what you want to do is try and make that final integral equal to that. So you may have to do it twice or 3 times sometimes, but usually twice, especially if we're talking about sine, because sine has to convert to a cosine and cosine converts to a sine. And then you can add it to the other side and solve. And if you have one term, well, you just make that your u and your dv is your dx. And there you have it.